Okay, here we got the pulse width modulation control. It is your LCD keypad shield is on the top. Your processor, you can see the processor is at the bottom. It's quite a compact little unit. If you look at it, I can fold it in my hand. And this is the unit that actually controls the fuel cell. You can see the interfaces done on the side. This is your input side. And this is your analog side. And this is the one that connects to your accelerator pedal. The pulse width modulation has been used on this side here. And I just want to show a little bit more of the unit itself. This is the first screen, the most important screen. Your current is coming from a 30 amp Hall effect current transducer, which is quite accurate. Your voltage is coming from a voltage divider, and if your car is running perfect and the charging circuit is good, this will be around 14.2, and you can actually see it's quite accurate display. We're using float values here, which is very accurate. But what is important here is the power side. This is the power of the cell, and this is the loading. The loading is very, very important. If you're running at 105% here at full load, that means your electrolyte is a challenge. Your electrolyte must be, your ratio, your strength of your electrolyte must be increased so you can run lower. So those two figures is very, very, very important. Now let's look at the other screen. Now this is the maximum I flow. At the moment we recorded 12.64 amps. That figure is very, very important, because if you want to control at 8.3 and you've got a capacity of 12.64, it means you got good control. But if you want to control at 8 amps maximum load, and you only got 6 amps here, that means you cannot control the unit. So this immediately gives you an indication of the electrolyte strength. Now this is your minimum I. You can actually set your minimum current through your cell. This is 0.25. The word here is set. So you can actually select this page, and you can actually go up or down, whatever you want. And you can see that the system is self-checking. You cannot put it more than 3.99 amps. Normally 0.25 is perfect. That's about perfect. Values are safe. You can go to your maximum. Oops. There you can go to your maximum amp. You can again set, and you can set this whatever you want it to be set. When you set, there's a cursor to say that you can give an input to the left hand side of the point, and you can actually go and set it whatever you want it to be. Maybe you select and you want to go a little bit higher, and you can play with your fuel cell inside your car, no problem, no whatever. The water level is on the bubbler. There's an interlock here, and the signal is good. So though there is water in the bubbler, the system itself is safe. This is a very important page. You got two different modes of control of your fuel cell. You get a constant I. That means when you're idle, it gives you a X amount of gas, and when your pedal is full flat down, you're actually giving the same amount of gas right through from zero load to full load. This is not recommended to use, but you can actually run this control system to see what benefits you're going to get out of your fuel economy. Again, select is the word. You press select, cursor is flashing, and you can take it to your variable I control, save the value. Now it's in variable I control. What it does is it takes a signal from your acceleration pedal and feeds it to this unit here, and when you do not press on the accelerator pedal, with other words the pedal is full up, you got idle speed, and idle speed will then give you the minimum current on this unit here. And when you press your pedal full down, immediately it will give you your full load current when your pedal is fully down, and anything in between will be in relationship with the current to the cell. This is a very, very difficult control loop that we have done. This actually consisting of 2 loops, and in C++ we use mapping, where we instantaneously on the value of the accelerator pedal we give load, and then we have a closed loop system that measures the current, and then could do a minor adjustment on the current to ensure that you always have the maximum current that you want to do. Now this is a fuel load, your fuel cell status, which is very important. You select it and you can actually put it off. Don't want to do that now. But you can actually select it. There's no need for changing it, pulling fuses or getting under the bonnet. It's software controlled. You get a calibration page. This is on your pedal only. And you press select and it just follow the instructions. It's saying the pedal must be up, and to begin press up. So your acceleration pedal must be in the up position. You're not pushing on it. And what it does is taking a lot of readings, probably about 70 readings at certain intervals to determine the 0 position of the sensor. And it's saying, and it's in relationship of each other. The pedal is up, so you press up. It's now doing calibration of the 0 value on the acceleration pedal. It is now done. It says press pedal down. You press your acceleration pedal full down on the system, and as soon as you're done, you press the down button, and it's now taking the value of the acceleration pedal and get your calibration values. So there's no tools needed, there's no metering needed, there's no technical expertise needed. You just follow the screens, and it says pedal down done, begin up button, you press up, and it's saying 0, 0 because there's no signal for max and minimum. So you can actually verify that that signal actually makes sense, and it tells you that the calibration is done. You press left, values is saved, and it's done. And you can go back to your first screen. Very simple, very effective. And you got all the power to play with your fuel cell, minimum, maximum current, 2 different control systems. You can do what you want to do. Your calibration is simple, easy, no tools needed. And I think this is a very, very effective unit that will actually change a lot of the operation on the fuel cell.